Okay, good morning, everybody. I'm Vanessa Demuth. I'm a professional geologist, a registered environmental health sanitarian, and a certified well inspector with the Minnesota Department of Health. Today I'll be talking about our overview of Dakota County, Minnesota's private well and water testing programs. We have a vast program, and I can't talk about everything we do or have done, but I will talk about our water well permitting program, water testing, our PFAS and cyanidine results, and our future well sampling. You should know that our programs and staff do not receive any county tax levy. We operate from funds from our surcharge on garbage disposal at one of our 5 landfills, our well permit fees, and from federal and state grants. Minnesota, land of 10,000 lakes. We share a border with Canada to the north, and we are about a 7-hour drive northwest from where we are here today. Dakota County, shown in red on the map, is where I've worked since 1993, and my supervisor, Valerie Neppel, who's here today, raise your hand, Valerie, she is from Peoria, Illinois. We have 2 other well inspectors besides myself and 2 other scientists that make up our groundwater protection unit. Oh my gosh, I am so sorry.
I'm so sorry.
It's too many things to think about. Thank you.
My bad.
Okay, Dakota, Minnesota, in case you didn't know. All right, so Dakota County shown there in red, and then you zoom in to our Twin City metropolitan area for Minneapolis and St. Paul. If you've ever been to the Minnesota Zoo, then you've been to our county, and we often tell people where we are in relation to Mall of America. Who's all been to Mall of America? Okay, we are right across the Minnesota River. The areas in pink on this map are the suburban areas, and the areas in yellow are rural, where city water and sewer is not available. And 2/3 of our county is rural, and 90% of our county residents rely on groundwater for drinking water from either their municipal or private wells, and we have over 8,000 private wells. Our Department of Natural Resources created this map, and it shows that 62% of our county is either karst, mapped in red, or highly vulnerable, mapped in the lighter salmon color. I don't know what that is up there. So the highly vulnerable areas are predominantly covered by coarse-grained outwash, and we have a lot of gravel pits in those areas. We were delegated the well program from the Minnesota Department of Health because of our vulnerable geology, and we wanted more oversight, more inspections, and stricter standards than the Department of Health. We have sinkholes that develop every year in our St. Peter sandstone and underlying Prairie du Chien dolostone, and the Minnesota Geological Survey maintains a map of those locations. In 1989, we were delegated the authority over domestic irrigation, monitoring, remedial, dewatering wells, excluding public and municipal wells. And we currently have over 800 monitoring wells that are required to get an annual permit. And this is a state requirement, but we require the well owner to also submit their static water levels and water quality to us. And so we have this data going back to 1990, and it's currently being added to an EQUIS database. And over the past 3 decades, we've used a variety of, we've permitted over 5,600 new well constructions, over 7,700 well sealings, and we have well seal grants that pay for 50% of the cost to seal a well if someone applies and it is not income-based. And we expend about $80,000 annually on well seal grants. Over the past 3 decades, we've used a variety of sources for well seal grants, federal community block development block grant funds, our county landfill surcharge, which I mentioned earlier, different sources such as clean water funds, which come from the state of Minnesota. It is a 3/8% Minnesota sales tax. So Valerie recently applied for a Clean Water Fund grant for $200,000 that we were awarded for our well seal grant program. This covers some staff time, and we used interns to work towards completion of our well inventory. Whoops, went the wrong way. Okay. The goal of the well inventory is to have every parcel in the county mapped in one of 4 colors. Blue would indicate that there's an in-use water well. Gray means that there was never a well suspected on the parcel. Green means that all the wells were sealed, and red means that there is an unused, unsealed well. There's 2 ways we go about doing that. We ask the cities to share their water line information with us in a GIS layer. And so if a home predates the year that city water was available, and there is no sealing record, then a letter is sent to the landowner offering a well seal grant. In rural areas without city water, the intern uses GIS where we have plat maps going back to 1884 and air photos going back to 1937, and they look for areas of habitation. And if there is no sealing record and habitation and no well in use, then a letter is also sent offering the landowner a grant. Right now we're targeting wells in municipal drinking water supply areas. So when I made this map a few weeks ago, we had 37,000 parcels mapped, and since that time, the interns completed a whole 36-mile, that Vermilion Township area, and she started sending letters on that. So it's a very productive intern. And then we'll be using all the blue shapes for in-use water wells as a future mailing list to offer water tests. So we're the only county in Minnesota to require private well testing when a property with a drinking water well is put up for sale. And the sample must be collected by a third party and tested for nitrate, coliform bacteria, arsenic, and manganese. And on our website is a list of septic contractors that can collect the sample when they are on site doing the septic compliance. MDH requires new wells to be tested for nitrate, coliform, and arsenic, but because we have manganese concerns in our county, we require this as well. So anytime a well owner asks us what to test for, these are the recommended tests. This is exactly what the Department of Health recommends. We offer them an easy way to test. They can order a test kit from our website. Each test is $21. The well owner collects a sample, drops it off at our office, and a courier from the lab comes through to our building weekly to collect the samples. And then we send them the results with the treatment information if applicable. In 2018, I designed and started our first community-focused sampling program where everyone in the same city is offered a free water test, and the goal is to offer all 8,000 private well owners a free sample once every 5 years. We've already completed that cycle and we're going for another round. Valerie initiated the creation of a well owner handbook, and that is sent to every household along with an offer for a free water test, and they just let us know they want to participate, and then we mail them a test kit. The well owner collects a sample from the outside untreated spigot and then from their inside primary drinking water tap to confirm if the water treatment is working. Outside samples are analyzed for arsenic, chloride, manganese, and nitrate, and all inside samples are analyzed for lead. And then they're analyzed for nitrate if the outside sample exceeds 3, arsenic if any arsenic was detected in the outside sample, and then the inside sample is analyzed for manganese if it exceeds 90 in the outside sample. Everyone has sent their water tests, and then later a summary report of that whole city or township is prepared, and it's mailed to everyone in that city or township, whether they participated or not, and then they're also offered the opportunity to test, but then they have to pay for it. And these summaries are posted to our website. And this year, because we have a grant from Department of Health, and Ann Nelson, who spoke yesterday a couple of times, she is our point of contact for that grant. So we are also now offering coliform bacteria tests. And the state funds encourage us to partner with different groups and get creative about getting more people to participate in our free water tests, because right now our response rate is only 25%, and we want to move the needle on that. So what do we do with all this data? Well, we like to make maps. This data helps well inspectors advise well contractors, well owners, and it's sometimes shared with the state. This map depicts 4,477 nitrate results for the past 10 years from all of our programs. Nitrate is a concern in our rural parts. 52% of the wells had detectable nitrate, and 16%, or 757, were above the drinking water guideline of 10. Those are the dots shown in red. Yesterday, we heard from Sophia with Department of Health. She gave a talk about the 9 counties immediately south of our county, and there they're finding nitrate exceeding 11% of the wells. So we have a more serious problem. Not sure why the nonprofit groups that led that effort didn't include our county, but they didn't. We also have arsenic concerns. It occurs naturally in our rocks and soils across Minnesota, and 34% of our well owners have arsenic detected, and 24 have exceeded the drinking water guidelines so far. Oh my gosh, this is so hard, you guys. I'm not connected. It's like trying to do this, right? Okay. So 1% are above the drinking water guideline, and the highest was 50. And we have MDH funds for the first time, through Ann, to offer water treatment for those homes that meet the low income criteria. And the grant will cover treatment for arsenic as low as 2 micrograms per liter. You heard that right, 2 micrograms per liter. That's how protective the Department of Health is when it comes to arsenic. So we're very happy with these grant funds. The grant also pays to treat for nitrate, manganese, coliform, and lead. And we have 17 applications right now in various stages of completion. So because we have an ordinance and authority over water wells, Valerie was able to stop groundwater exportation from our county. There was a proposal to our Department of Natural Resources. It was actually called Water Train, where they wanted to withdraw 500 million gallons of groundwater a year from our southern part of our county, and that water would have been shipped via rail to the desert Southwest. The Department of Natural Resources rejected the application because of the deep aquifer they chose. Had they picked a different aquifer, I don't think anyone would have been able to stop them. We put a moratorium in place. In 2021, we changed our ordinance. And then later in 2021, state law was passed to also prevent this from happening. Let's talk about that 4-letter word called PFAS. Those chemicals that are used for their anti-stick and water repellent properties. Minnesota is like ground zero for PFAS. 3M started producing them right across the Mississippi River from our county. Our state received an $850 million settlement from 3M, and that did not include our county. So we have 4 cities so far where municipal wells exceeded the guidelines, and they have 4 years to treat or blend, but there's a proposal at the EPA to extend that deadline to 2031. Our Department of Health, being very protective, they created lower guidelines for PFOA and PFOS, and this map shows the 113 private wells that we have tested for PFAS, and this is just a drop in the bucket because, if I said, we have over 8,000. So 80% of the wells have PFAS detected. 39 wells exceed the Department of Health guidelines. 36 exceed for PFOA, 7 exceed for PFOS, 4 exceed for both PFOA and PFOS. I did some statistics, and I found that 3 of those PFAS listed there in wells was significantly correlated with the distance to a known biosolid application site. So we have a long history in our county of sewage sludge from municipal wastewater treatment plants applied to our agricultural fields. Those are mapped in brown. We have 443 known sites. Some of these fields received biosolids more than once, but there is no clear history or documentation of everything that occurred in our county regarding biosolid spreading. All the wells that were tested, they also have a septic system on their property. That could be a source of PFAS. These areas are agricultural. We know that containers that the pesticides were stored in may have had PFAS. There could be inert ingredients in pesticides that contain PFAS. And then we just learned recently that folks that applied pesticides to the fields would use a PFAS-containing foam at the end of the rows to mark on the ground where they had been. So that's a fun fact. And then also we know that PFAS is in our precipitation. In 2022, we had some money left over from a sampling budget, and I collected samples for microplastics. All 5 had microplastics detected from 3 to 84 particles. The lab took a photo of each sample, and pictured here is the microplastics fluorescing in a petri dish. This is the highest sample. It had 84 particles in 20 milliliters, which is about 4 teaspoons of water. There's no established drinking water guideline for microplastics. I'm waiting on the results of 6 samples we collected last fall. I wasn't expecting to find microplastics, so I talked to a well contractor, and he helped me identify 11 places in a private well system where plastic could be shedding microplastics into the water supply. This is a picture of an impeller on a well pump, and there are 7 or more of these polyurethane or PVC impellers. And I guess they could be made from stainless steel, but then the well pump would be a lot more expensive. Often when well contractors remove a pump to service it or replace it, they'll find these impellers worn down to nubs from pumping rocks and sand over time. And so, where did all that plastic go? The labs can also identify the plastic components, but that is an extra, the microplastics, but that's an extra charge. From 1999 to 2019, we conducted our ambient groundwater study where we sampled the same 77 wells up to 16 times for both geosourced and anthropogenic compounds to determine aquifer quality from wells completed in our 3 most used aquifers. We established baseline private well water quality and looked for trends, and this is the largest known data set of triazine and chlorocetamide herbicides and their breakdown products in a private well by a local government. We have over $1 million in data, over 157,000 individual water test parameters from private wells in our EQUIS database, and this was published to our website in 2020. It is its own talk, basically, but some of the highlights is that we found 62% of our study wells exceeded 1 or more drinking water guidelines. Any wells other than blue on the map exceed a guideline. 34% exceeded for manganese, 31 for nitrate, 3 for gross alpha, and 22% exceeded for the herbicide cyanazine breakdown products. The next few slides focus on cyanazine. This is likely the first time you've heard of it, and it was a very significant finding of our study. I bet everyone in this room has heard of the weed killer atrazine. Cyanazine is the herbicide atrazine with a cyanide molecule attached to it. The common trade name was Bladex and was commonly used on corn crops. USGS made this map of where they estimated its use, so the darker the color, the more intense the use, and so the Midwest, the Mississippi River Valley, and out in California were popular places. Cyanazine has 7 degradates. Let's see. Cyanazine was historically on a list of pesticides that we were testing for, but it was a parent compound. And then in 2003, we used a USGS lab that had a pesticide list that included degradates, and then we had lots of detections. There are 7 degradates, also known as breakdown products. On this chart on the left, you can see that there's a cyanazine parent at the top, and then the arrows show all the different degradation pathways. The 2 circled at the bottom in red, DDA and DIA, are common to atrazine as well. And the numbers in red are the frequency that the degradates were detected in our study. We were advised by the Department of Health to sum up all the degradates and compare it to the drinking water guideline for total cyanazine, which is 1 microgram per liter. There are several health concerns associated with cyanazine. Developmental, it's a suspected teratogen and mutagen, female reproductive, liver and kidney systems, and it is a potential carcinogen. Okay. This map depicts the total cyanazine results from samples collected either by Dakota County or the Department of Ag. 70% of the 774 wells sampled had cyanazine detections, all the well dots shown in color on the map. 9% exceeded the drinking water guideline, those in red dots. The Department of Ag created a cyanazine work group with us and the Minnesota Department of Health. This year was the first time that the state provided funding for water treatment for these affected wells. So we administer the program for our county and for the 2 neighboring ones. Free reverse osmosis systems are provided for wells that exceed 1 microgram per liter. So all 66 of our wells with cyanazine over 1 are being offered a free RO or a buyout of their rented system. The Department of Ag is actively sampling for cyanazine across Minnesota's surface and groundwater, and their data is annually published to their website. And MDA's concern is that it's not going away, and our ambient studies show that it's just going to the deeper aquifers. You can take a picture of this slide if you want. I know it's in your packet, but it might be hard to read, but these are the 2 labs right now that can test for the cyanazine degradates. And our Department of Ag hired 2 vendors to synthesize cyanazine degradate standards so these 2 labs could develop an analytical method using LCMS-MS. So both Dakota County and MDA have used these 2 labs. It's about a $200 test. You get atrazine, cyanazine, and their degradates. And if you live in any of those corn growing areas that use cyanazine, I'd encourage you to test for it. You might find it. And then our county formed the Emerging Contaminants Work Group. We have staffs represented from several different county programs and offices. The work group's goal is to inform and educate the public about contaminants of emerging concern. We've created a webpage for the public regarding PFAS. We provide updates to the county board regarding emerging contaminants. In 2025, I'm in charge of soil and sediment sampling for PFAS in areas potentially impacted by those land-applied biosolids, the effluent from our wastewater treatment plants into the rivers, and smokestack emissions from our local PFAS manufacturer. We're also going to be testing private wells for neonicotinoids. And then our county is targeted right now for 12 hyperscale data centers. And so that is on our radar as well. And with that, I will take questions. Okay, all right. How are you able to offer the test kits for $21 or are they subsidized? Oh, okay, sorry. We've got two different things going. Anyone, anytime can order a water test kit and any of those parameters are $21 each. Then we have our community focus program and that testing is for free and it's offered to everybody in the township or the city that we're targeting that year. And how are they subsidized? Yeah, the testing that is available to anyone throughout the year, that is not subsidized. That is what the lab basically is charging us. We actually might mark it up maybe at $2 or something. So the next question, are there big fluctuations in the monitoring well static levels over time? Sounds like interesting data. Right, yeah, we do look at well, we have a hydrologist and he retired and he was the one who would do deep dives into our water levels, usually upon request in areas where there was a project going on where we wanted to know. But our Department of Natural Resources has an observation well network statewide, and those are actually the wells that I usually go to when I want to look to see like the drought conditions and how that is affecting our water levels. And so actually we will see, depending upon the aquifer, we will see a lot of decline, but then it will bounce up over the winter. So right now we're not in like a state of like groundwater depletion right now, we're kind of maintaining. Why test some things from an outside tap instead of just collecting all samples from the kitchen sink? Oh, okay, well, it's a geologist in me. So I want to know what is in the aquifer. So that's your outside sample, right? The untreated sample before it hits the household plumbing. And so we want that for our own information to share with the drillers, to share with the state. And then, of course, at the primary tap, that is what they're drinking. But people, you can have the fridge dispenser, right, with your carbon filter. You can have a person with that, an RO spigot, and someone in the house who doesn't like either of the two, and they'll still drink from the tap. And so which tap is representative of that home? We just let them decide. We just tell them to take a sample from their inside primary drinking water tap. Are homeowners responsible for treating PFAS in their wells? Does 3M take any responsibility for the contamination? So in Dakota County, we are advising them to use carbon or reverse osmosis to treat their wells, and we have no way to help them. 3M is not helping them pay for this in Dakota County. However, that $850 million settlement mainly applies to the county adjacent to us where 3M was located, and they are paying for water treatment in the homes, which is a whole house carbon. They're also paying to connect people to city water, and they're also paying for the cities to put in these massive carbon treatment facilities. Where does your funding come from and fees? Okay, so I mentioned at the beginning that we don't get any county tax levy, but we do have 5 landfills in our county. And so every time garbage is brought to the landfill, there's a surcharge charged to that hauler, and that a portion of that surcharge goes to an environmental fund in our Department of Environmental Resources. And so that helps pay for our salaries. And then we also have our own well permit fees. And then we do get a lot of federal and state grants. Were homeowners with microplastics surveyed to determine what practices or product usage influence the microplastic levels? Well, no, that's a good idea. We have not done much with the microplastics yet because we only have 5 results. And I was told to maybe stop testing for microplastics because there are no drinking water standards, but then I had an opportunity to get 6 free tests last year through the Minnesota Pollution Control Agency. And so those were sent off to the University of Minnesota Duluth lab, and it's taking a real long time to get those results. But yeah, it'd be interesting to see what they're doing. But another thing I thought about is testing the septage that comes out of the septic system for PFAS to see, compare that with the house. There's a lot of things. I have a lot of ideas. Some of them are kind of gross too. But yeah, we have a lot of PFAS. It's not going away. It's going to be here forever, and it's kind of job security, I think. Okay, thank you.
Thank you.